Hi, everybody. My name is Tara Dunham. I'm the program manager for the new Climate Tech Incubator being launched here at the Rue Institute. So this program started with a seed funding from the Governor's Energy Office, enough to get us started, and then we will plan to grow it from there. We're launching publicly next month, so we've just been doing all the behind the scenes work, and part of that work has been building our ecosystem and partnering with people like E2 Tech to do speaker series and other ecosystem events to get people interested and engaged and build the climate tech ecosystem here in Maine. So thank you so much for coming to our second event in the speaker series. Warren and I will be around. Warren is the director of the incubator, and we will be around to chat with people and tell you more about our program and what's upcoming, and do a lot more of these events in the future. So thank you so much. I will welcome up our partner here. You want me to do slides for you?
Sure.
Oh, where you got your
I can just carry this computer over.
computers are.
So thank you for joining today. My name is Eric Howard. I'm the executive director of the E2 Tech Council. We're here today because the state of Maine and the people of Maine are putting in heat pumps all over the place. This map that you can see on the screen is all of the partners who are working with Efficiency Maine in the installation of heat pumps. And putting in heat pumps requires some thinking, because pretty much every house in Maine and every business in Maine is unique in terms of how it was put together. Where's the living room? Where's the bedroom? Where's the kitchen, etc. And so it's not a cookie cutter approach for figuring out the costs and the installation requirements. And so today we're going to have a speaker who will be talking about how to fix that particular problem. E2 Tech Council has been around for about 20 years. We work with businesses, with individuals. We convene gatherings. Every Monday we do research for the state of Maine and the Governor's Energy Office on the price of heating oil. We've also had a long-term partnership with the Maine Technology Institute in terms of promoting technology innovation. And I'm pleased to note that my predecessor, Marty Groman's here in the room with us. And so if you've got questions about the history, Marty can ask. Last fall, he was elected mayor of Biddeford. I started at the Tech Council 52 weeks ago. This is my 1-year anniversary this week.
I was demoted.
You were promoted. So there you go. E2 Tech, we've got more than 225 member companies and institutions. Our emails go out to about 4,000 people. And we have lots of partners, of which the Rue Institute of Northeastern is one of them. Here's a quick little summary slide talking about the fact that we're a convener, we're a catalyst. We try to be a credible resource of information, and we're a connector. I think maybe this is one of Marty's slides, or is this from your predecessor?
Yeah, I think Jeff Marks deserves credit for that.
Yes, exactly. This slide's even older than that. Today, again, we've got Eric Ampley, who'll be speaking about his Maine startup, which is trying to help accelerate the adoption of heat pumps. And so I am going to stop my screen share and let Eric give his presentation. He's doing it virtually. And we very much appreciate him spending some time with us at lunchtime today. Thank you.
Awesome. Thank you, Eric. And thank you both to the Rue Institute and E2 Tech. It's a real honor to be speaking today. I'm a longtime member of E2 Tech. It's a great organization. I encourage everybody to become members and participate in these events. All right, so I'm going to talk to you today about my business, Ampley. We are on a mission to make heat pumps just a no-brainer solution for both contractors and homeowners to benefit both people and the planet. And we're doing that by building what we think is game-changing software for heat pump professionals. So I'll just share a little bit more about myself. I want to frame, why the heck did we start Ampley? What's the core problem that we're trying to solve? We'll get into the solution. I'll actually do a video demo of our product. And then we'll chat a bit more about the technology that's really powering our user experience and what we're doing for the heat pump market. And since it's a relatively small group, we'll probably pause there for any questions around that first part of the presentation. And then I'll get into a bit more of the business for all the entrepreneur nerds out there, just to share a bit more about some of our go-to-market strategy and accomplishments and other details about our business. And then we'll wrap with questions. All right, so I am Eric Fitz, co-founder of Amply. I lead all things technical for our business, product engineering. My background is in mechanical engineering and physics. I have a master's in mechanical and been in the climate tech space for really my entire career. I started off designing wind turbine blades at General Electric, doing the air acoustic aerodynamic design for their first generation of blades, and using large advanced multi-physics computational fluid dynamic platforms to do that type of design work. I worked as a management consultant for a number of years, advising Fortune 500 businesses, utilities across the country, startup companies, hospital systems, on everything from rooftop solar strategy to utility rate design to building energy efficiency issues, and also helped the Department of Energy in a number of different models like the solar advisory model and appliance standards for walk-in coolers and freezers. I like to think of myself as a building science nerd. I've been modifying and improving the homes that I've lived in and helping my friends and family navigate heat pumps and solar and batteries and weatherization for many years. And part of that is the reason that led us to start Amply. My co-founder is a longtime friend of mine. We met in college. We've known each other now for over 25 years, which is hard to believe. And he leads all of the kind of go-to-market side of our business. All right, so why Amply? We clearly are not decarbonizing the US housing sector fast enough. As you may know, the residential sector in the US represents about 20% of all carbon emissions. And if we want to get anywhere close to the targets we need to hit to avoid some of the worst effects of climate change, we've got to decarbonize those buildings faster. And it's clear that heating, ventilation, and air conditioning is the most important problem to solve in the decarbonization space. It's where the overwhelming majority of the carbon emissions are coming from, primarily from the fossil heating systems in homes. It's also where a lot of homeowners perceive the comfort and benefit of this electrification transition. And it also is one of the hardest retrofits to do in existing homes. Moving from a fossil-based heating system to heat pumps, which are the obvious technology solution, there's a lot of considerations and challenges that need to be thought through, particularly around the design of the system. And so after we spent hundreds of hours with our prospective customers and users in the field, observing their challenges, what we've seen over and over again is that what we're asking heat pump installers, particularly the comfort advisors, the salespeople that are going out into people's homes, what we're asking them to do is almost impossible. In spite of that, there are a lot of successful companies out there. One of the first big challenges that these companies are up against is that they're taking on a massive risk. An HVAC system, obviously has huge impact on the comfort of the home, but it also can have health ramifications. And if things go wrong, you have major impacts on utility bills. So these contractors are making taking a big financial risk, and if things go wrong, they can have human health impact as well. In order to design a system properly, you need to understand what's going on in the home. That requires some building science understanding, doing careful calculations to understand, what are the heating loads in the wintertime, what are the cooling loads in the summertime. And that takes a bunch of time and effort. Once you understand what the home needs, you then need to design a system that meets the requirements of the home, but is also tailored to serve the specific needs of the occupants, of the homeowner that's living in the building. There's a bunch of challenging and complex issues around that process. And now rebates. So there are great programs like and organizations like Efficiency Maine that have been leaders in the country on making rebate processing simple and straightforward. But things are getting more complex with the Inflation Reduction Act. This is challenging across states. It's different even by municipality. And this is a whole new thing that comfort advisors, that these heat pump salespeople need to navigate and kind of do a lot of gymnastics in front of a homeowner trying to explain whether they qualify for certain rebates or don't. And there's a lot of uncertainty and challenges there. Last but not least, these salespeople need to do kind of traditional sales. They are trying to educate a homeowner on the equipment, what it's going to look like, where it's going to go, how it's going to perform, why a particular manufacturer's product is the right fit for their home. And it's just a tremendous amount to juggle. All of this is while they're thinking about the competition. Sort of the Jan in the van or Chuck in the truck that's just going to swoop in and not take any of these careful steps and process and undercut their price and steal the job from them. So there's tremendous pressure for them to do all of this work quickly. And with their current tools, we see this regularly taking 5 to 10 hours for a single sales proposal, not let alone actually installing the project. And my motion light just turned off. Let me just turn that back on. There we go. All right. So the best installers, the best heat pump professionals out there, they are piecing together a workflow that's really fragmented and time-consuming to actually address all of these challenges. So currently they're doing some kind of preparation before they go out in the field to visit a home. Usually they're checking a real estate database or maybe a customer relationship management system. And once they get to the home, in addition to doing a basic walkthrough and sales process with the homeowner, they got to take a bunch of measurements. They might be using a digital tape measure, and they're going through and measuring the square footage of the building, all the different rooms, measuring window sizes, and they're jotting all this down typically with pen and paper. They then have to take all of those notes and enter them manually into another piece of software to then actually calculate the heating and cooling loads throughout the year. Because these existing products are so cumbersome, many contractors are just using a rule of thumb method that leads to some pretty bad outcomes around designing and sizing the equipment appropriately. There's additional documentation that needs to be captured. So in order to fully understand the install, you need to capture pictures, notes, indicate where outdoor equipment should be located, indoor equipment, and they're using their phone, they're using other tools for this. So a whole other workflow. And then they got to design the system. There are some existing equipment manufacturers, software tools to help figure out, can this outdoor equipment, work with this piece of indoor equipment? But each manufacturer has a different system. It's if you're a typical contractor, you're often selling, let's say, Mitsubishi and Samsung. So you have to learn 2 different tools and keep track of specs for a lot of different equipment. Once you've done all of that, you got to build the quote. There are more tools for that process. Often these are so challenging that a lot of contractors are just using a Word document that they're manually updating for each project. And last but not least, they got to manage rebates. We see this, each contractor has a different process. It's a combination of Excel spreadsheets and pen and paper. There's people spending hours a week just making sure that this is going smoothly for their business. So our solution to all of these challenges is to build a single platform, what we call the Heat Pump Copilot, that eliminates a lot of these steps or just dramatically streamlines the process to avoid human error, allow our customers to do this work accurately, do it correctly, and do it fast. I'm going to show you a quick just video demo to give you a sense of what the heck we're up to. All right. So we start off.
Before you even arrive.
I'll turn off this audio. We start off just by entering in an address so we can pull in data from external real estate databases to help the salesperson understand what they're walking into. It also reduces data entry for some future kind of calculations that are being done. And then we're using LiDAR and machine vision to scan the interior of the home and measure and build a 3D model of the home in real time. We're capturing all the components in the space, like windows, walls, doors, and identifying those objects so we can do a real-time heating and cooling load calculation you can see right now. You can make adjustments to all of the assumptions of the construction details of the building, so window panes, wall insulation. And then we can visualize the equipment. So we can bring to life for the homeowner what they're actually purchasing, what it's going to look like. We can draw the refrigerant lines on the outside of the building, which is a big concern for homeowners as well. So we've got the load calculations, we help with equipment selection, and then we roll up all this information into a beautiful design document that can be shared with the homeowner, it can be shared with the install team, so everybody's on the same page. And all of that we can do in just a few minutes instead of hours. So the main benefits for our users, again, they're primarily the salespeople that are dedicated to making these home visits and are typically designing the systems. The primary benefit is it helps them grow sales. It increases their sales conversion rates. We see this over and over again with customers that start using our product. Homeowners actually understand what they're purchasing, and it's really compelling to see a comfort advisor take careful measurements and see the detail that they're going through to make sure that they're getting the right system for their home. It absolutely saves a tremendous amount of time. Hours and hours of work we can accomplish in about 15 to 30 minutes. And yeah, it really blows their customers away. It's great from a sales engagement perspective and setting expectations. But it also leads to just better outcomes in general. When you design the system correctly, you get the right equipment installed, you end up having happy homeowners for years, and the equipment actually performs the way it's designed to. All right, so let's get a little more into the technology. So LiDAR. LiDAR stands for light detection and ranging. It's a sensor that's now built in to all of the latest Apple products, so iPad Pros and iPhone Pros. Our software runs on an iPad Pro, and all it does is bounce light off of objects and measures how long it takes for that light to come back to the sensor. Knowing the speed of light and how long it takes, we can pretty accurately measure depth or distance. And so at about 60 frames per second, a point cloud of LiDAR light beams are going out. And you can see the representation of that point cloud. It's actually an RGBD image. So a typical image with the red, green, blue, but also with this depth information embedded as another layer in the image itself. So in the middle here is a visualization of that depth information. So you can see as the cooler colors, that's closer to the camera and the LiDAR sensor, warmer colors, that's farther away. But also embedded in the data is some confidence information. So as you see the LiDAR, it's interacting with the 45-degree slats, this little window shade, possibly interacting with the glass behind it. There's a lot lower confidence in that depth measurement. And that's really useful information, particularly from a machine learning perspective, to help understand the data and figure out what to do with it and help with labeling. So LiDAR ultimately is helping to get precise measurements. But there's a tremendous amount of work that Apple in particular has done. They've really moved the state of the art forward in a massive way. So about 2 years ago, Apple released a paper after spending several years doing a massive data collection campaign to be able to train and make some of the capabilities that we're leveraging possible. So they went throughout the world. I believe it's over 50 different countries. They scanned over 1,600 rooms. And in many of those rooms, they took 3 or 4 scans of the space using a super high resolution LiDAR scanner, in addition to using their products to scan the space, and ultimately captured almost 500,000 frames of video, of images that contain all this depth data, and then painstakingly labeled all of that information so that they could later help build capabilities to detect objects in the space. So this is an example just from the paper that they published a couple of years ago, where they are labeling a dresser, a bed, a window, and other objects in the space. And so this was a massive, massive investment by Apple. So we are heavily leveraging all of that work, and it allows us to, in real time, on device, do this layout detection and augmented reality overlays to help guide our users in the scanning process when we're capturing and building a 3D model in real time. It's a convolutional neural network. CNNs are really ideally suited for pattern recognition. They're very commonly used for image processing. This is all running on Apple's hardware, so all of their latest devices have an Apple neural engine built in that's designed for doing these type of machine learning computations in real time. So there's one pipeline, one CNN that's handling the basic kind of layout of the room, and then there's a second one that is handling object detection, and that is processing all of those RGBD frames. It is slicing up a 3D representation of the space into 15 centimeter cubes or voxels. So voxels are kind of equivalent of pixels, but in 3D space, and allows us to identify objects in the space. So at the most basic level, we can see what's a window, what's a wall. We're also able to detect other objects in the space. So tables, a sofa in this case. And from that information, we can derive other layers of information like, oh, we must be standing in a living room because we haven't detected a refrigerator, but we see a sofa and a table. Therefore, we must be in a more common living space. All of this is happening in real time on device without connection to the internet. The output from all of the data that's flowing in from that real-time imaging is a data model that captures all of these surface and object details. So information about walls, windows, doors, and floors, and then those objects in the space. And we've got very detailed geometry information, where these things are placed in three-dimensional space, their size, and that allows us to build the 3D model in real time. So all of that explanation, you saw in the video demo, for a typical room, this is a relatively large kitchen. The scanning process took about 15 seconds to capture all this geometry. And as soon as we have all that geometry captured, we can then do real-time calculations to figure out what are the thermal gains and losses in this space. So we're taking that geometry. We use the GPS on the device to look up historical weather data and design conditions. We use the compass on the device to figure out the cardinal direction of doors and windows. And then we've got assumptions and details about all the construction materials in the building. And a user can interact with this model very intuitively, easily. They can just tap on any one of these surfaces. So here I am selecting a wall, and I can make adjustments to those assumptions, and the load calculations change in real time for that particular component or for the rest of the building. There's other measurements that are accessible for other use cases. So I can just see this entire wall surface is 32 feet long and 10 feet high. I can see the net surface area. So excluding the windows, what's the total surface area that is useful for future weatherization workflows that we're working on. And I mentioned that we're automatically assigning the cardinal direction of transparent glass doors and windows just using the compass on the device. So a little bit more detail on the heating and cooling load calculations. We've built our own proprietary engine that runs offline on the device. We are pulling in the weather data from ASHRAE's latest design condition database. We are computing all of the building envelope conduction through walls and windows. We can handle things like garage partitions, where you've got a garage space that's attached to the home, and you've got a wall that's dividing between that garage and interior space. We're modeling things like solar gain on an hourly basis. So knowing the location of the device, the latitude, the orientation of the window, and the window geometry, we can compute the solar angle of the light as it's affected by overhangs in the building. So we can very accurately model how the sun shading from the window overhang or lack of an overhang is impacting the solar gain for unique location, unique window, unique orientation for a space. We're modeling air leakage, both latent gains and sensible gains. So there's loads that are created from humidity that are coming into the building from cracks in the space. We're computing loads associated with ventilation. We handle imbalanced ventilation. So if you are potentially creating a negative pressure in the building that might induce more air leakage, more infiltration due to ventilation. We handle duct losses. So if there is a duct work in an attic space that's in really harsh conditions in the summer and the winter, we can calculate all of those details as well. And then last but not least, handle internal gains like heat that's generated from appliances, from occupants in the building, plants, other factors. So again, all of this, it takes a tremendous amount of time to explain it, but we're doing this in real time, in milliseconds on the device, while the person is just holding an iPad, walking through the building. So at the end of it, the output is a highly visual, data-driven design that just takes minutes instead of hours to create. So on the left here, this is what a traditional heat pump sales proposal looks like. It's a bunch of text, it's a bunch of model numbers, and some pricing information that for most homeowners, they really have no idea what it means other than that it's going to cost us a certain amount for them. So instead of that, we are creating a highly visual proposal that's got the 3D geometry, it's got visuals with augmented reality representation of the equipment, where it's going to be installed, and we've got those load calculations to back up that this is the right size equipment for the particular application for this home. All right, I'll pause here and see if there are any questions before I talk a little bit more about the business.
One of the things I found in Maine is we've got the oldest building stock, and how I don't see any process in your software how you assess the insulation of these structures, some of which may be very high with weatherization that they've done through efficiency Maine rebates, or no weatherization at all. And how are you assessing that?
Yeah, great question. And I actually might pull up just a live example on my iPad. But the simple answer is that we are in the video demo where I showed where we were entering in the address, we were pulling in information from a real estate database. We make very basic assumptions using the age of the home. So when the year it was built, to reverse look up what the building codes, what the energy codes were at that time, just to make a crude initial assumption. But a user can adjust any of those assumptions in real time, while interacting with a 3D model. So for this example, I'd indicated that this wall was made out of a structurally insulated foam panel that's got log siding. If I want to tweak this and say, hey, this is definitely, it's a frame wall, 2x6 with R19 insulation, I can quickly make that change and apply it to all the walls in this space. So super easy to make those adjustments. If particularly an example you mentioned where a homeowner's done a huge renovation just a couple of years ago, they've done some weatherization, we can certainly account for those changes.
Okay, there were two other questions in the room.
Mine was mostly answered, but as a follow-up on it, your LiDAR can tell like from door and window casings if you have a 2x6 wall or if it's an older 2x4 wall or whatever?
We can't at the moment. It's a great question. Our best practice that we're trying to teach comfort advisors and sales folks to do is just look look at a window, and you can actually pretty easily visually see, is this 2x6 or 2x4? But it's something we're thinking we might be able to help measure automatically at some point, but at the moment, no.
Eric, hi. I'm just wondering if you can explain what you developed here in the technology set versus what is off the shelf or from Apple. Just trying to understand what's proprietary to you.
Yeah, sure. So, I mentioned that the training data set, that's all Apple's work. And then, Apple has built the hardware that makes it possible to do what we're doing. And then they have made the accessing, the LiDAR point cloud and all this kind of real-time data relatively straightforward for us to do. But the thing that's really unique that we've built completely ourselves is, once we've captured the geometry, we are taking all of that and processing it and figuring out, is this a wall? Is this a window? And then applying those building science and physics calculations. So our load calculation engine is completely proprietary. That is our own software that we've actually had third-party certification done to prove that our calculations are following a national standard.
We've also got an online question from Rob Aldrich.
Yeah, thank you. This is a great presentation, Eric.
Thank you.
I'm curious how you incorporate it. It sounds like you select the tool helps select specific equipment. I'm curious how you incorporate manufacturer info, equipment parameters.
Yeah, right now it's generic. We are working on getting all the data, all the performance data for various equipment. So right now, I'm visualizing this wall unit. We can visualize, floor units. I can visualize ceiling cassettes, but these are just sort of generic images. We show the nominal capacity of the equipment. And so typically a contractor, they at least know, they know their product line fairly well. So selecting the nominal capacity is a good starting place. But eventually we'll fully comply with Manual S, which is the standard for appropriately selecting equipment as opposed to just doing the load calculations of the building.
And does it do ducted as well as ductless?
Yeah, yep. So we support ducted and ductless. The basic way that we support ducted is just we can visualize new ceiling registers.
Okay.
But the load calculations are really about the building. That's less about the equipment. So loads can be done on any home for any type of equipment.
Awesome. Thank you.
Yeah, sure.
Go ahead. Given that you're creating 3D models of people's homes, from a data privacy perspective, where is this data repository at? How long is it kept? Who has access to the data?
Yeah, so we share the data with homeowners. They get a copy of the proposal. It's under our terms of use and privacy policy, we are retaining the data. As you can see, we're very, for like these 3D models, we're just capturing the geometry information. We're not taking, a full scan, a visual scan of the interior of their home. So like we're not capturing artwork and other very kind of personal and identifiable information about the building itself. And we are using industry best practices to encrypt and store this information. Ultimately, the reason why we're retaining the data is there are future workflows we want to build that can really enhance the experience for both homeowners and for contractors that allows to analyze the data in an anonymous fashion and build new features on top of that data.
Eric, who's the person who actually makes the video? Is it one of your contractor? Is it a contractor or is it the homeowner?
Great question. So our end user is the contractor. So typically, there's a salesperson. When you go to Efficiency Maine's website, you look at their vendor list, you contact a heat pump contractor. The first person that's going to come to your house is the salesperson. They're going to be using our product to do the walkthrough of the home, build this model, do the design. But we are thinking about a future where we might put the product in the hands of homeowners directly. We really want to refine what we're doing. It's just got to be totally streamlined before we're putting it in the hands of consumers.
Okay, we have one more question here in the room.
Yeah, Eric, my name is John Wallace. I'm actually a certified energy manager. So seeing this, I took my exam many years ago, but your product looks quite fascinating. It looks like heat pumps for the masses is within reach with that type of system. So very innovative. And just a quick business question and one technical. On the business side, are you able to do more than just look at heat pumps? Can you layer in the considerations of maybe on-site solar, rooftop solar, to other sorts of systems that would go into a full building energy analysis and right sizing thereof? Is that possible with your system?
Great question. Not right now, but we want to get back there. Actually, the earliest incarnation of our business, we were doing whole home electrification. So we designed and installed retrofit about 20 homes across New England. We were doing solar, weatherization, heat pumps, heat pump water heaters, storage, EV charging, you name it, and started building the software that you're looking at today for our own internal use. We realized we were taking on too much too early. So we pivoted to, instead of selling directly to consumers and homeowners, to build software for heat pump contractors specifically. But we want to get back to, in the longer term, really helping the entire electrification movement, really raising the bar on design and building science in the whole home retrofit space when it comes to these things that impact energy and comfort in a home.
All right, great. And then just a quick follow-up on that. Are you focused primarily on air source heat pumps right now? Or are you also looking at geothermal heat pumps as well?
Yeah, we're primarily focused, from on air source, just because that's the largest volume of products that are being installed. Our product, we have customers that do geothermal and are using our products. We just don't have visuals for that equipment. But you can certainly do all the load calculations and do the whole design process using our product today for geothermal.
Thank you.
Yep. Is there one more hand raised?
Caitlin.
Thanks, Eric.
Hey.
Quick question from a salesperson's perspective. What do you envision the walkthrough process looking like?
Yeah, so the walkthrough process.
I'm wondering if every room in the house needs to be scanned.
You broke up a little bit, but I think I caught your question. You're asking, what does a walkthrough process look like? Do you need to scan every room in the building? The short answer is the walkthrough process just follows what a typical salesperson currently does. They need to walk through the entire home today to think about placement of indoor equipment and other details. So instead of just walking around and kind of eyeballing stuff, they're just walking around with the iPad. The scanning process for 2,000 to 3,000 square foot home using the iPad takes about 15 to 20 minutes right now. And you do need to capture a scan in every room. And it's really seamless and easy to do. And getting the room by room scans ensures that we can get room by room load calculations, which are particularly important for ductless mini splits, where you've got often many pieces of indoor equipment serving different parts of the home. So we can appropriately match the equipment and visualize it for the homeowner. All right. Well, if there aren't any other questions at the moment, I got just a few more slides to talk a little bit more about the business. and then we'll wrap things up. All right, so obviously we are focused on HVAC contractors, particularly companies that are almost exclusively installing heat pumps. But we have an increasing number of customers who are traditional HVAC companies that are seeing the interest in heat pumps and are adding it as a new product line to their existing business. But there's also a lot happening in adjacent contractors kind of space. So we have seen multiple surveys that report that a large percentage of solar contractors are thinking about adding heat pumps as a new service, a new solution offering. And so we're trying to figure out how we start to reach some of those solar companies. And similarly, weatherization companies that are doing insulation and air sealing, they're tired of giving away great leads to HVAC companies after they do weatherization and building envelope improvements. And so many of them are also starting to add heat pumps as a new offering. So we're willing to help anybody that's installing heat pumps, and this market is really starting to grow. Our go-to-market strategy is we're trying to reduce customer acquisition cost, and we're experimenting with a bunch of different methods and having success through a bunch of different channels. First and foremost, we are doing direct cold outreach to contractors. We're just walking into their offices. We are making cold phone calls and actually having quite a bit of success just reaching contractors that way. We are attending and partnering with a number of trade organizations like the Air Conditioning Contractors of America or the Building Performance Association, which tends to draw the most forward-looking, innovative HVAC companies across the country. We are starting to work more and more with distributors across the US. Not only do distributors sell equipment to heat pump installers, they often are the source of education, technical support. They have very strong relationships with those companies, and it's a great way for us to build more awareness of our platform. A couple of different software platforms we are working with to build native integrations. So Service Titan is a tool that a lot of contractors use for managing their customers and inventory. We see opportunities there to integrate with those type of platforms to further expand our reach. Certainly, existing energy efficiency and utility programs are very important. We've had a recent webinar with NYSERDA, so like doing a training session for all of their HVAC vendors, training them on Manual J and tools like ours to make that process of doing load calculations much easier. And obviously, they're the big source of rebates and a lot of the driver for awareness and interest in heat pumps. And last but not least, manufacturers are certainly aware of the best installers across the country. They offer all kinds of training, and we are working on partnerships and relationships with the biggest players in the space. So yeah, the market shift is really happening. It's super exciting. The last 2 years, heat pumps have outsold gas furnaces in the US. This is from the Air Conditioning, Heating, and Refrigeration Institute data. They track all of the shipments of equipment across the country. So this shift is really has already happened, and we think the market is going to continue to grow. The total addressable market, if you include the growth in HVAC companies, solar installers, and weatherization companies, I think it's well over $2 billion a year. In the near term, we think it's about a $160 million opportunity for us. So not only is there a significant business opportunity, crucially, we think there's a real opportunity to have impact on carbon. So the US entire residential sector represents 20% of all greenhouse gas emissions. That is about a gigaton of CO2 per year. If you just look at HVAC, it's about 430 million metric tons a year just from the heating and cooling systems. And with our current forecasts and rate of growth, we think that we will be avoiding about 1 million metric tons of CO2 by 2026. And as we expand across more of the US, that'll continue to grow. We are pretty conservative in these estimates. So nationally, we're assuming about 2 metric tons per home per year. But in a place like Maine, where we're primarily using heating oil for our heating systems, it's more like 6 to 7 metric tons per home when we switch off of those systems to heat pumps. And it's been pretty exciting over the last few months. We're getting some real market traction. We're approaching triple-digit number of customers. We have 30% month-over-month growth in our monthly recurring revenue. I'm not showing the y-axis value here, but as a software entrepreneur, this is a nice looking chart. It's up and to the right, and we've got a lot of great customers from across the US. So a few more accomplishments. We bootstrapped this business for the first 18 months before fundraising. This is how we learned a tremendous amount from what's really happening with our customers, what their real challenges are. We've done over 700 user research interviews. That's homeowners, it is heat pump contractors, and it's folks across the business. So it's the folks who are doing sales, running operations, the technicians that are doing the installs. And we've spent hundreds of hours riding along and just trying to live in the shoes of our customers. We've raised about $1 million. A good chunk of that has been from grants. So we won a Massachusetts Clean Energy Center Innovate grant. We've also, we're very thankful for $100,000 of grant money from the Maine Technology Institute. We won the longest running Clean Tech Accelerator, the Clean Tech Open last year, and also Gorham Savings Emerging Business Award last year. And then the balance of our funds come from angel investors, as well as one of the largest heat pump contractors in the US. We've got customers now in 20 states and Canada. We've launched a podcast. It's the Heat Pump Podcast. Please check it out. We thought there was a big gap in the market for heat pump specific content. We are interviewing some of the best heat pump contractors in the country to tell their stories, how they've been successful. And last but not least, we have achieved full third-party certification from the Air Conditioning Contractors of America just in early July. This is a really big deal. This is the standard for the methodology for doing load calculations, and it's a big deal that they gave us the stamp of approval that our proprietary model is doing what it should do to calculate these things correctly. All right, what's next? We are very interested to get into more automated equipment selection. There was one question about this earlier. We are trying to just capture and acquire all the data that's necessary to do this. So we want to take the thousands of pieces of equipment that are being sold in the market, capture all of their performance characteristics and all of the permutations of their possible configurations so that we in real time can recommend the optimal piece of equipment for a particular home for the specific application, while still complying with a equipment selection standard called Manual S to make sure you are not misaligning cooling and heating capacity of the equipment. We see a path to provide electricity consumption forecasts using that performance data, our building science model that could be useful, obviously, for setting expectations with homeowners about what's going to happen with their electricity bills, but also to support workflows like, hey, I know I'm going to install heat pumps. I'm thinking about solar. How much is that going to increase my energy consumption so I can size my solar equipment correctly? We're working on improvements to our augmented reality visualizations of equipment. So there's a lot of exciting stuff to do there. And last but not least, we think there's a tremendous amount of opportunities around machine learning and artificial intelligence. We are, trying to capture data in a really clean and structured way that will enable a lot of new and innovative features that will primarily be driven by machine learning. All right, so that's my presentation. Are there any more questions? If we don't get to your questions, please feel free to reach out. You can email us, check out our website. We'd love to chat some more.
Yeah, Warren has a question here.
Eric, do you have future fundraising plans?
Yes, at the moment right now, we don't think we'll need to raise another round for quite some time with the growth that we're seeing and revenue that's coming in, but likely we'll do a priced round in another 12 to 18 months.
Hey, Eric, it's Marty Groman. Just incredible what you've done with this business since you first took a look at it 18 months ago or 2 years ago. It's just amazing. And I want to provide a testimonial as a person who's had heat pumps installed at 2 different residences. And the first time around, I had the inexperienced chuck in a truck, as you said, and the refrigerant drain back lines were done incorrectly, and the unit is undersized, and so forth. And the second time I had an install done, I was right in their face to make sure they did everything right. I just think that you've got a lot of potential here. I really want to emphasize that potential a little bit by encouraging you to, you may already be doing this, but manufacturers should be paying you to have their data in your system, or certainly, if not now, soon. And another thing that can often be part of a program like this, which is very common in the roofing industry, is that you would somehow certify your contractors as well, that they are, amply certified as, or whatever it is. So I just wanted to throw those 2 business model opportunities at you.
Awesome, thanks, Marty. Yeah, I appreciate that. We're the powered by Amply concept in particular. We're trying to figure out how to do that the right way, and it's been interesting. We've had some of our customers ask us, is there like sales collateral that we put on our website that says we're powered by Amply? And we're like, well, that's interesting. Maybe we should do that. So yeah, love those ideas.
Yeah, take a look at the roofing industry and see what GAF and Owens Corning do as a model.
Cool, I'll do that. Thank you.
Eric, you mentioned that there were users in about 20 states. Since heat pumps are also used for cooling, are you finding any traction in southern states where people are using heat pumps for air conditioning purposes?
Yeah, absolutely. So we have customers in cooling dominated markets, heating dominated, mixed humid environments. So customers in Washington State, Texas, Louisiana, Maine, Massachusetts, New York. We're really pretty diverse geographically at this point.
You mentioned rebates and the different product specifications and trying to make sure that that's part of your system so it's up to date. But I'm curious, how do you make sure it stays up to date as those manufacturers are also updating it on their websites and specs? And then in the same vein, how often do you upgrade your software publicly so that the users are noticing these changes when they're using them?
Yeah, great question. On the software update piece, we're an agile software development company. We're releasing updates at least once every week or 2. So we're constantly improving the software and making sure our users experience, those changes on a rapid pace. And then with regard to the data, it's an interesting, hard problem. Thankfully, most of the manufacturers' product lines tend to last for about 3 or 4 years. There's been a bit of a shift most recently around moving towards A2L refrigerants, which are actually semi-flammable refrigerants. So there's going to be a big wave of new equipment that's coming on the market. But those relationships that we're trying to build directly with the manufacturers is, we think the path where we can, get access to their data directly. So when they change their database, our database updates automatically. But it's a long process to negotiate those relationships with OEMs, but it's something we're certainly trying to figure out.
Just I have one more question. Your focus is, I guess, homes, but I'm curious, how much do you work with like condos and apartments and just broader commercial buildings?
Yeah, great question. Our load calculation standard that we're following can be used for from Efficiency Maine's perspective is considered small commercial. So for like a coffee shop, we can do load calculations on it. For up to a 4-story building, so it could be a condo or 4-unit apartment. The manual J standard can be used for those size buildings. Anything more complex than that, that starts to look like a hospital or a school, that's a different calculation methodology that has to be used. So we're not doing that today.
Great. Thank you, Eric, so much. I'm going to hop in and wrap up our event. Thank you all for joining us and talking with Eric today and asking really good questions. I'm sure it was helpful for him as it was for the rest of us to hear those questions. We will be around for a few minutes to talk about the Climate Tech Incubator and the RU Institute and Northeastern University if anybody has any questions for that. And we encourage anybody online to reach out as well. We are eager to meet everyone and to tell you what we're up to. And we will see you at our next E2 Tech Speaker Series event, which is in September. What is the date?
12th, I believe.
Yes, September 12th. It's on E2Tech's website. We will see you.